Sweet. Hello, everybody. Welcome to the wasmCloud community meeting for Wednesday, July the 12th. Today is going to be all about WIT. We've got a demo around witty providers, which is a fun pun that Jordan came up with, and I'll let him explain a little more around what this effort means, something that we've been doing on the maintainer side, and going to get to show off a little bit today. And then I've queued up some discussion in the end for what in the world is WIT, why wasmCloud is transitioning to use it, kind of where it plugs in the WebAssembly world. And I really just wanted to set up some time so that we can all talk about it. We can brainstorm. Anybody who's coming in and tuning into the community maybe as a new person coming or contributing, understanding what WIT is and why it's important. So I will go ahead and stop taking the floor because I think I'd like to hand it over to Jordan. So go ahead and you should be able to share and everything, Jordan. So go for it.
Cool. Let me see if I can get this working. Hello, everyone. Please wait. How do I do? Whatever. Okay. Hope there's nothing too personal on my monitor. Okay. Can you see that, Brooks?
Yeah, looks good.
Cool. Yeah. So about a week ago, maybe a little longer, I decided to take a peek in.
You just want to make them full screen, Jordan. You just want to make them full screen.
How do I do that? Oh, I'm an idiot. Of course, I know how to do that. And then I can probably do what?
There you go.
Okay, cool.
And then sorry, Jordan, one more thing. I can see on the live stream it's a little blurry. If you could get a little make this AARP approved and zoom in a little bit.
I'm trying now. I gotta figure out how to make Arch work for me. Okay. It's like overlays over overlays. Okay, and then how do I do this? Plus. Good, Brooks? Tell me when.
Maybe one more.
Okay.
Yeah, I'll let you know if it's because the stream's a little behind, but I just want to make sure that's visible. I think it's good.
Okay. Cool. Again, so yeah, I looked about a week ago. I started looking into WIT, and Bailey will go into it in much more technical detail, but it's essentially just an IDL, a lot like Smithy. However, it was built for the WebAssembly ecosystem. So I took on the challenge of, since Go is the point of least friction and I'm the most familiar with it, trying to remove all the Smithy generated interfaces and replace it with the WIT IDL interfaces. So my starting point was having to identify in WIT what like wasmCloud's RPC bus looks like. And there's a PR in wasmCloud interfaces, but this is essentially what I came up with, right? So if you were to pull up the Smithy version of our core contract, you would see it pretty much maps one-to-one, with the exception of a few things, like the option types aren't in Smithy and, well, map types, but we won't get into that. But essentially, while the contract is like 95% similar code generation, there were some changes that, they're not one-to-one Smithy to WIT. So I took that on, and what I did was I took the provider SDK that we already have in Go, and you'll see now everywhere where we did have like interfaces or wasmCloud interfaces core TinyGo, we've now replaced it with this core, something that lives in the repository with it. And if we dig into that, which is not going to be on that screen, let me pull this up. Let's see. Nope, not that one either. I try to always have these up and ready. which generates something extremely similar to what we had in Smithy. So what you're looking at here on the right is if we were to go and take the Bytecode Alliance's WIT biogen binary that they have in their GitHub repo and run it over this WIT file, we would get this output. And essentially what we've done is, replace the Smithy with this stuff. So the demo is still a work in progress, but it's fun on two parts. We have a provider and an actor running in wasmCloud with no more Smithy IDL interface pieces generated. The only thing I can show you that provider is running right now is you can see in Nats here that the 30-second health check that it does is running. You can see the ping pong provider here. And we can see here that we can actually query the actor. You say ping, it says pong. If we were to link these two right now, you would see the provider send an invocation over to the actor. It passes the all of the wasmCloud security checks. However, I do have a bug in there that is that the actor is crashing. But that being said, by next Wednesday, I hope to have that fixed and we can link them, and then we'll see a full round robin WIT only actor provider example. So it's it's not that exciting to look at, but this does align us or begin to align us with where is it? Yeah, the migration over to WIT and away from Smithy. So that's really it.
I'm going to see the source.
Which, okay. So actually, if we were to,
would you mind just zooming in a little bit on this window too? Perfect.
Okay. Well, actually, Bailey, you'll be happy to hear that, oh my God, maybe too much. All right. See if I can get it in one screen. So, sorry, Brooks, I'll do there. So the providers themselves are actually identical to what they were before, with the exception of the provider here is what's doing this SD key is what's doing all the heavy loading. However, you will see we will have this go generate line at the top of every file. And what that's going to do is, while my understanding is wasmCloud will have all the WASI cloud interfaces built in, that doesn't address custom contracts, much like my extremely advanced ping pong contract, which is when I ping pong, I take a ping and I return a pong. So we have to have a way to do the custom contracting. So in the provider now, which will all be hid behind wash build eventually, right? We write go generate. It generates this lovely file, code over here, which is essentially the two types I had and an interface that says, anybody that satisfies ping, which you would actually see this interface satisfied in the actor because the way this is written, it's a provider to actor call. But the actor and provider share this contract. And then this file called hand done. So this is the work that still has to be done. So at the moment, Smithy via Weld generates all this code for us, and it's pretty much just serialization code. Close. Right now, I have to hand generate it all. However, it is as straightforward as Weld as the old Smithy piece used to be. So as soon as we I guess we're going to call it bindgen wasmCloud or something like that. As soon as we're able to write the wasmCloud specific pieces of the code generation, which would be all of this, this will be ready for what I'll call the community to start playing with. Right now, if you want to do it, it's absolutely possible. You just have to hand write all of this, which means I was just kind of looking at old examples and pulling in the new types. So you'll see, like right here, this is a new generated type. What else, Bailey? What else can I show?
I like that. I like that. Do you mind showing a little bit on like the workflow for how you built these things?
Yeah.
AKA just
Okay.
go generate, go build.
Yeah. So let me get in there. So ping pong was actually still done with wash new provider. It generated this structure and I changed it quite a bit, but all right, no, whatever. Okay, so right now, right, if we were to start this from new, right, we would run something like what sure I have it. Okay, we would go generate, and you see now go generate is actually, if you recall, a wrapper around with bindgen. So actually, if we were to run this command, it would get the exact same output. And then when you go into gen, right, we have all of the files necessary to make this work. You know, the C calls and everything to make it work with, I assume something like wasm time. We are using it more as a general purpose IDL from this perspective. So we are actually able to remove all of the C type code, go into pingpong.go, remove this, and then remove the functions. And then at this point, we essentially have our contract that we would get in Smithy. So a little bit of massaging has to happen, but we're pretty close to having something that's integrates pretty well with wasmCloud. Oh, Brooks has his hand up. Brooks, your turn.
Hey, so yeah, I think if I gathered right, this ping pong example is kind of like a net new example that you were using for this
Correct.
This demo. You know, as we keep working on this, and I know that this is like the beginning of the transition. What do you see the migration path looking like for providers? Like on the wasmCloud side, we have, you know, 7 or 8 capability providers that are open source and use the Smithy interfaces. So
I'm glad you asked that, Brooks. Here's the one that I am internet famous for, right? So this is the one provider that I've written, and it uses obviously the core interfaces and Go. Since it is not a custom contract, pretty much what'll happen is we will replace these 2 lines with the output of what go generate put. So it'll be in the same directory, but in like generate. And then the only real update, which I can probably minimize by changing like some of the generated names are long and obnoxious, but it'll just be coming in and changing the types, like right here. So this will say wasmCloud core dot wasmCloud core type link definition. And you'll have to change all that out, but the logic itself wouldn't actually change at all. It would just be type changes, which I think we can minimize by paying a lot of attention to the code generation.
okay, so it sounds like that's really awesome to hear. It sounds like a good bit of the changes are just kind of like editing some imports and generate lines at the top of the file. And then as long as we're kind of careful, if we can make it so that the new generated type is the same name as the old generated type, it should be a relatively easy transition because it's just on kind of like the types side.
Correct. I mean, quite frankly, since like Go, I don't know if Rust does this, but Go, since you can have these import aliases, right? As long as I can match the names, we can import the new one as core as well. And there shouldn't be any code changes. So yeah, that just has to do with paying attention to how we name these moving forward.
Awesome. Yeah, I think on the Rust side, it'll just come down to changing the interface for the module path that we're importing from, and the type names can stay the same.
Yeah.
Sweet. My hand is still up because I had one more question. As far as like an actor developer, so like I wrote an Echo actor that links to your Tailscale HTTP server, right? Or like a, any actor. What needs to change there? Like when we release the new providers using WIT as the interface definition, what do you have to change on the actor side?
So it's actually going to be fairly similar. Both the SDKs will, I'm trying really hard not to, but they might be a breaking change, but right now they're not. So there will be just, you'll update the actor and the provider Go modules, or I guess Rust crates. And then that's it. The way we're going to lay it out, I think, is for something like a custom contract, or I guess recommend, right? The directory will look something like, it'll have a high level WIT directory with the custom contract, a provider directory, and an example directory. The example directory will hold an example actor. So that being said, the example actor will be generated from something like wash new actor. So it'll be pretty familiar, I guess is the word I'm looking for. But that being said, I think if when we move forward, all these new contracts will have a example provider and actor in the repo with them, so it'll be easily referenceable.
Okay, that's really cool to hear. It sounds like there should be really few changes needed on the actor side, if any. All our examples are going to be updated to use this kind of format anyways, so it should be that should be a nice transition.
I mean, this ping pong actor I have right now, right? It actually requires no code changes. Well, that's not true, I guess, for deserializing for the custom contract, but minus the deserializing for the custom contract, if I were to flip to the old Smithy models, it should, I say that very timidly, still work.
Yeah, I think that makes sense, right? Like with as we change interfaces, as long as there's nothing super fancy going on and the types match up, then it should all serialize, deserialize, just as it did before, no matter the source interface. I think that'll be really important to keep in mind as we keep working on this. And if there's breaking changes, then so be it. I think there's a lot of things that are going to change, depending on what happens with the standards. So just be transparent on that.
Yeah.
All right. Anybody have other questions for Jordan? Cool. Then I think we can go ahead and move into the discussion part of the call. I specifically set up a little time to talk about WIT and, with this specific effort, talking about WIT as the interface definition language for our capability providers. But of course, WIT is going to end up being so much more than just for this. And I think Bailey is easily the best qualified and best explainer of this. So I'll go ahead and throw it over to her to go through, WIT and all the things.
Yeah, I think it was a good call out, Brooks, that we probably need to take a step back and kind of look at an overview of where this fits into the whole ecosystem and the set of standardization efforts that we're doing. So WebAssembly, there is a WASI working group within WebAssembly, and they have done an initial proposal for, of course, WASI Preview 2, but it builds on top of this new standard that allows us to do things like working with high-level types and letting us link together with other different components. And so a WebAssembly component is different from a WebAssembly module, but if you understand that we're talking about high-level types, and we're introducing this new ABI, well, when you look at the binary that's output, you'll see that the WASM module is the first like 8-ish bytes. And for a WASM component, obviously it has a component. But then when you look inside it, you'll see that a WASM module, it's basically passing just numbers around. Whereas with a WASM component, I'm able to use high-level interfaces like logging. And so one of the things that we learned while we were working on WASI Preview 1, we being the W3C standardization effort, is that it's really difficult to version and support ABIs. But it's significantly easier if you're able to do things at a higher level. And so instead of defining these with ABIs, we've started defining them with an IDL. And that's what we talk about when we're talking about WIT here. And WIT stands for the WebAssembly Interface Types. And so we can use these interface types to talk between, in this diagram that Lynn Clark drew, on the left-hand side, that computer is basically representing the WebAssembly host. So I can load a WebAssembly guest component and use that to talk to the host with these high-level types. But I can also link together and talk to other components that are written in other languages, but over these high-level types, I can talk to them. And so that's basically linking high-level types. And there's this other third thing called platform virtualization and layering that are the key 3 features of the component model. And if we dig into like how are all of these different standards layered, it all starts on top of the WebAssembly core specification, and that's your WebAssembly modules. And a component actually wraps a WebAssembly module. Today, it fully encapsulates a single WebAssembly module with shared nothing linking, but we are actively working on shared everything linking to be able to support Python. And so in that case, it'll be one component to many WebAssembly core modules. With WASI Preview 2, it's all defined in WIT. That is the thing that we're basically standardizing, is this is the set of APIs that WASI Preview 2 represents. And that is built on top of the component model. And that's the part that people most get confused. But the main thing, like the goal of all of this, is that anybody now can come and build modular interfaces. So I expect communities like Envoy Proxy or Open Policy Agent to have their own sets of interfaces that everybody basically uses, and it's provided by a registry, and we can build and share and version these independently. And so I'm showing you this, but I do want you, I need the caveat here. It is not officially standardized yet. Everything is very much in action, but we're reaching a point now where there is a level of stability. We've got a specific version that we're targeting right now of the component model ABI. And when I talk about what that ABI is, I'll hit that in just a sec. But I just wanted to give this caveat in that we know there's at least one more feature that we're missing before we say we're not changing the WIT for component model specification, and that's for resources and handles. So what we basically just saw from Jordan is he was able to build a WebAssembly component, but he had a few other steps leading up into that to be able to test some things out. Actually, Jordan, did you show off a component, or were you showing an old school actor?
That was just an actor.
Actor with Smithy?
No, well, I apologize. That was a component then.
Dope. Okay, cool. All right, I didn't lie. So yeah, basically when what we're talking about here on this side of it, the WASM component that we're producing, we're talking about building basically actor components. And so Jordan used a variety of tools to get to the point of having outcomes a component. Today, none of these top level languages support targeting WASI Preview 2 directly. Almost all these languages that I'm referencing here, they say WASI Preview 1, and then we do this adaptation step to get it into being a component. But Rust specifically is like this close to having a WASI Preview 2 target. And so you can skip that adaptation step for that one. And so once you have it, you also want to generate your guest language bindings. So it's a little bit unfortunate right now that WIT BindGen generates C bindings for Go. That's kind of ugly, but it's leveraging basically an existing Rust crate that obviously we started with Rust. And so it's reusing a lot of that existing code to be able to build a lot of those things. And so that's your guest language bindings. And that's the part that lets the your code. So actually, let's dig in deeper. I'm going to go past that and talk about the shared nothing linking spec, right? Okay, so your component instance has imports and exports, and that is defined by your WIT definition. Those are the APIs basically that say what goes in and what goes out. And when I say it fully encapsulates core WASM module, what I'm showing is that all of its memories, its tables, globals, all of that isn't accessible to anybody that's talking to it. They talk to it through the imports and exports. And so with shared nothing linking, we get a ton of really cool benefits. Like we're able to actually do principle of least authority even within a single application, which is something that has before the component model existed, something that nobody could really do. You basically had a giant environment variable blob, all the keys to your database and to your key value store, to the way you talk over your message broker. And basically anything that was in your supply chain could just say, hey, I know what the environment variable for AWS keys usually looks like. Let me just peek and get those in. And now I have access to your data. So by saying, hey, this library that is only supposed to be doing the thing that does maybe my messaging, it does not need to know how to talk to my database, right? And so I can pass the right things in and out. And then that means that all of the boundaries for what these apps do is clearly defined. And that lets us do a lot more modular style programming. So there's a ton of different benefits I see in the future. Yeah, Liam?
Oh, no, finish the section you're on. There's the question from YouTube in chat there. I think you may want to maybe talk about, if I understand the question right, maybe take a step back and do a little comparison between what we're abstracting from maybe containers versus this.
Yeah, that's a good question. Okay, I'll finish this last bit and then I'll answer that. So when we talk about lifting and lowering types, and that you see some of that in the guest generation that Jordan was showing for making the thing that he was generating work within a WebAssembly runtime. What that is lifting and lowering types. And so when you're at, when say you've linked together Rust and a Python component, the Rust representation of strings is different from the Python representation of strings. And so when I link those together, I have to know how to bring it up to a WebAssembly, lift it to a WebAssembly, or lift it to my Rust string type when it's coming to me in Rust. I also need to know how to take it down to the I32 representation within a WebAssembly module. So when we talk about lifting and lowering, we're talking about being able to get it into a common representation, which is what's defined by the canonical ABI within that's kind of like part of the component model spec. And then there's getting it into what will let you work within all of these different languages. And so to address the question about, component model as an abstraction, it's definitely true when people think about, okay, well, I put things in a container. And so I bet I could find a better slide for this. But basically right now, when we actually, you know what, I'm doing it. I'm going to go ahead and grab a different slide deck because I worked really hard on this picture and I want to share it. And that was from wasm.io. Oh, I've drawn too many things. Tell you what. Nope. Yeah, so this was a really cool talk that I got to do with somebody from Microsoft. And when I described this, I wanted to make sure that people understood how this breaks down and compares to a container. And so when you crack open a container, there's lots of different processes, and containers are focused on figuring out good ways to virtualize Linux. And that includes way more than what people think that includes, especially a lot of different security roles around that, like virtualizing the Linux kernel and having a hypervisor OS for it. And when you crack open a container, something else you see is that there are not just apps or maybe just one app, there's also lots of different system libraries. And so that's why in the wild today, and I think this was by Sysdig, they found over 85% of containers used in production have a higher critical CVE. And the reason for that is that there's just so much stuff that is in a container and so many different pieces that have to be maintained and updated. And so when I'm talking about what is a component, what I'm talking about is cracking open that one spot, that one place where the application is, and then breaking down the way that we build apps today from first principles. So in this case, I'm showing like, hey, I want to use a key store, value store, and I want to talk to AWS. Well, when I do that, I typically am going to pull in something like DynamoDB's API. And that might also bring in and install additional system libraries or more things inside my container to be able to do that. And so this import is one of many different imports that are going to exist in my system, right? Typically, I'm not just talking to a key value store. I'm doing a lot of other stuff. So I have a lot of other libraries I brought in. If I'm doing messaging, it might be Kafka, and that one definitely brings in a system library. And so when I crack open that app, that's the thing that I want us to find a way to make those smaller, more efficient, and built in a different way. And so when we talk about the component model, we're talking about finding different ways to plug in these different interfaces and have a representation. And you can kind of think of these as like Lego blocks or shapes, where you want each side of those shapes to line up. And that's how you're able to ultimately compose them. And so you take a component and you plug it into the host that matches all of those same APIs. And so if a host has WASI Preview 2 support, it's got the right knobs that any component that wants to use WASI can plug straight into. So I think that part was really fun to show off and talk about with the community. And when we talk about how we build things within the wasmCloud ecosystem, we're not just doing components locally on one single WebAssembly runtime. And what I'm seeing a lot of people do is build capabilities directly into the host, which means I've taken all those CVEs and all of those vulnerabilities everywhere else, and I've kind of put them all in the same box again, and I made them all run within the same process. And that's kind of failing. Now, there are a lot of folks that are trying to find different ways of making that safe. And to be clear, this box here, that's my sandbox, right? That's the thing that guarantees all the safety reasons for why I'm also interested in building with WebAssembly and WebAssembly components. So I think I can probably stop there. There's, this is something I like to talk about a lot. I sped through kind of, what it looks like to link things together, but I guess one thing I didn't say is that I can take Rust, Go, and JavaScript, and when I compose those together, I can either use the wasm tools compose command, or I can use crate. So every tool within wasm tools project, which is part of the Bytecode Alliance, it has all of those are represented via crates. And so we're going to be able to embed those crates and make a really easy experience for folks to be able to build these and work within the wasmCloud ecosystem. Liam, I see your hand.
So if I could restate one of the things that I think I just heard you say is that there's some compelling reasons that we don't want to bake these standard capabilities into the host because that moves us back to the same problem we have in the containerized world, where we are including all of our non-functional requirements at compile time, static versions of them, as opposed to the dynamic loading at runtime, which is what you're saying when they're external to the host. In that way, a platform like wasmCloud or a commercial one could load the latest version that's the most recently built, that's up to date, that catches the latest CVE or log4j at runtime as opposed to compile time. Did I understand that right?
Yeah, that's one of the major places. I think that people can find ways to sandbox some of those capabilities. I think there's lots of different options, and there's other ways of, defining like a DY-lib or like a dynamically linked thing in other WebAssembly runtimes. I know some folks are trying that, but obviously we have that with our link definitions and our ability to have distributed capabilities so that we're able to run them right next to where they need to be. And that decouples our host from revving individual versions of those capabilities. So if there's a vulnerability in, say, the HTTP server, that vulnerability isn't in my host. That vulnerability is only in the HTTP server, and that's the only thing that I need to update. And then from there, it's all about relinking to that new version, and that's incredibly powerful because the thing that we need to get away from is turning the crank across the world every time we have one of these major CVEs. This is how I like to describe it, which is like if we have another log4j event, which is like a common library that's in everybody's code, for the sake of the planet, am not interested in finding ways to recompile all of our code all across the world. And I really just want to fix that one thing that's wrong. And components let me do that. Yeah, we didn't really talk about world files. That's its own conversation, but I like talking about it. If anybody, I'm seeing CJ's comment there. So yeah, part of WASI Preview 2 is defining basically two world definitions. And the way to think of a world file is that it's a collection of imports and exports. So those interfaces that I've been talking about, those high-level interfaces. So every line here, each one of these imports, these are things that we're standardizing individually, those interfaces. But then we're also standardizing the collection of these so that together they make something whole that you can think of as like an execution environment. And so one of the first ones most people will be used to is probably like running a CLI world, which is really similar to what we had available in WASI Preview 1. And many of these APIs will be familiar, but some of these are new and awesome, like the poll API. And that's kind of the underpinning for letting us do like back buffering and some early async behavior. WASI Preview 2 itself won't support native async. A lot of that is going to be handled by our WebAssembly runtime to begin with. It has a table and it's keeping track basically of all of those pollables. But we're able to start writing code that takes advantage of that from the guest side. And so this is a simplified version so that it would fit on my slide, but basically this is what it looks like for the CLI world that we're standardizing. And the very bottom here is the run command, which is like, okay, I have a CLI and I just, think about any CLI that you run on your command line, you just run it. That's basically what that is for the for components that want to run in WebAssembly worlds that support command modules. Is a different way of saying that. We didn't talk about the difference between reactors and commands, but I don't think that's particularly interesting here. So any more questions? I mean, this is, I could give a keynote on this easy, but I think there's a lot here. What's exciting is that this set of work, right, is basically stabilized. I can build stuff on this and it hasn't broken me in a few weeks, which is a big deal for me at least. And a lot of the activity for the other side is there's another world. So there's the WASI CLI world. The other world that we're going to standardize as part of WASI Preview 2 is the HTTP proxy world. So you could think of that as an app that needs HTTP and some logging, some of the same capabilities here within the CLI, but otherwise something that actually supports HTTP. And that kind of shows two very different runtime environments, right? It's not just about trying to find a thing that kind of emulates POSIX, but like not really, right? Because it's missing all of those other things that Docker does. It's why it starts so fast and it's why it's so tiny. And there's a lot of reasons to do it that way. And I'm not particularly interested in finding ways to virtualize Linux badly. What's more interesting is finding new ways to write applications for the modern world. So these components are declaratively linked. They might be statically linked. They might also be dynamically linked. But there's a little dynamic, depends on your definition. You can do this at runtime, and that'll give you that feeling of dynamism. I don't know how to say it. I'm just not gonna. But yeah, I'm interested in more on that question. CJ? Or wait, sorry, that was L. Well, I'll answer that more. CJ, you want to answer?
I don't want to answer, but I do have a question, and I'm not sure how to not sound dumb, but you made the distinction previously between designing and maintaining an AVI and this being an IDL. Is that basically the distinction between changing the WASM spec itself to be able to interoperate types versus creating a wrapper around the build system that can build these abstract components that interface together?
Yeah, so with WASI, previously we kind of defined a strict set of APIs that represented an ABI, an application binary interface. Whereas this is defined using independent WIT definitions, and each one of those independent WIT definitions are IDLs, and it's not about separating out the build itself. So our previous incarnation of this was actually just with WebAssembly modules. So as part of the core WebAssembly specification and WASI, basically the things that came out were more numbers for it. And now what's different is the thing that comes out is like, literally like the binary syntax of the .wasm is different. And so it's more than just the build, I guess.
Right. Thanks. Yeah, that clarifies a little. I would have to sort of dig in, I think, to ask a more intelligent question. I'm definitely interested in how this works at a low level. So,
I mean, we haven't yet had a call for like implementers on a lot of this stuff, right? We have component model implementation weekly calls where we've been talking about building this implementation and giving feedback back to the specification. So there's the W3C standardization process, and then there's a group of us working within the Bytecode Alliance to build an implementation and give feedback to folks like Luke Wagner, one of the original creators of WebAssembly, who's the key champion for the component model. We go back and give him feedback like, it's not going to quite work, I don't think. And so within WASM time is the first reference implementation. And so that was a really long-winded answer of there are no wrong or stupid questions because a lot of us are figuring this out and it's all being invented right now.
Gotcha. Cool. Yeah, I might hit you up on the Slack to get maybe links
Totally.
to those conversations because that sounds interesting. Thanks.
Liam?
I just wanted to add, I think that, a lot of the folks at Cosmonic are, working hard on planning or implementing a lot of this in wasmCloud right now. If you look at a bunch of the work that Roman has been leading behind the scenes, we're implementing this stuff live. So I think one of the things that I'll continue to ask across our team is that, we do this stuff in the public Slack and we have the conversations there, because I know that I feel like I had to listen to it a few times to get all the pieces to fit together and understand how they were really coming together in this elegant way. It's very similar to the long-term ambitions of where wasmCloud started, 3 or 4 years ago, pluggable components. Some of the details are a little different, Smithy versus a WIT. But the amazing thing is that as I've watched Roman and Bailey and Victor and all the other folks that are working on this effort in the background, it's how much of our current ecosystem translates directly over. So conceptually, a bunch of our tooling, all of these sorts of pieces. So I think we should double down and make sure that we are over communicating on wasmCloud Slack and continue in this meeting to sort of do these weekly updates. I don't know if we would want to do one every week, Bailey, for the next few months. If that doesn't feel too heavy, maybe we just give a demo of, Roman, what you're working on. And that would be great. Because I know that I feel like every week my mind is blown as this stuff's really come together. And, I didn't mean to leave out names. I mean, Jordan, Kevin, Brooks, Taylor, everybody I feel like on our side is really working hard on the implementation of this stuff.
Yeah, Victor too. Um, yeah, just I wanted to add on just a little more there, just to say that this is such an exciting time for wasmCloud in terms of like what we're doing with the WebAssembly module. And now that we are seeing some, we're like into the phase where we're rapid prototyping and seeing working POCs with WIT and Worlds and WASI Preview 2, all of those things are super exciting. And, they've kind of graduated from something that we can think about as maintainers as like, gosh, I can't wait until this works. And now it does. So expect to see a lot more activity on the standards side and communication there. It's a really exciting time.
Yeah, I want to take another swing at Elle's question here. This is an example of a world definition. Another way of thinking of a world, sometimes I just think of them as a component themselves. So when you build a component, and I run a command like wasm tools wit, that will print out the wit definition of that component. So I don't actually need a wit file to know what the wit definition of a component would be. If I have a component, it has all those high level types listed there as I was showing in the binary output. So this one's kind of fun because this shows a little bit more on that linking of being able to link to multiple guest components. So in this case, it's contrived, but I wanted to have a greeting application that greeted from Go, Rust, and JavaScript. And I think I've showed this off at the community call before, so I won't like go and show off too much of this demo, but specifically around world files, this is an example of that, of how do I bring in all those different libraries and then run them. And so this app, when you look at its source code, is pretty simple. You've got the bindings for those different libraries,
Bailey,
a Go one and a
sorry to
Rust one and
interrupt.
JavaScript. Oh yeah.
Zoom in a little
We
bit.
should talk about conferences.
Or no. I just want to interrupt it. Ask if you could zoom in a little bit. It's just a little blurry
Oh,
on the live stream. There's not
sorry,
that
y'all.
much code, so you should be able to fit it.
Yeah.
Even if big.
Is that better?
Yeah. I think that's
Okay.
better.
Yeah. So, even in this simple code, I'm able to do the JavaScript to the Rust to the Gopher call, all from my one Rust app that was defined by that one world definition here. And so when I build this thing to make it work, I used a little cheat code within the WASM tools compose, which is a CLI, and kind of told it where I put all of these WASMs. And each one of these themselves is a WebAssembly component. And this should still work. So you should be able to clone my project here and give it a whirl for yourself. And this kind of walks you through some of what it looks like for a lot of those CLI commands. But for many of these, for like the Rust ones, there's just one step to be able to start and build a component, which is really great. But I think I want to leave time for Liam to talk through some of the conferences. I've enjoyed also getting to work with him on them. I'm getting really excited about one of the events. I wonder which one Liam thinks it is.
Conferences are way less important, Bailey, than your epic explanation today. I gotta be honest, I want to pull out that whole part of the video and just publish that as a separate video. Like, you were just like, let me just drop this like it's hot. But it's a quick update on conferences. WasmCon is well underway. We had 96 submissions, and the CFPs are almost finished being reviewed. The program committee, of which Bailey and I are two of the chairs, are trying to get the schedule out next week. It's going to be exciting. I think we'll have around 36 talks. There's also training sessions available. This is September 6 and 7. I would encourage you to get registered. We weren't sure about size. I could see this one selling out pretty quick. There's also an additional event that's happening on Friday of this same week that's being put on by the Bytecode Alliance. Now, the official name is going to be Hack the World, where it'll be a one-day hackathon where we take some of this new language tooling for components like cargo component, componentized JS, componentized Pi, etc. And we look at some of the top frameworks in each language, and we look to see how many of them we can turn into components. It should be a really fun day. Well, we're hoping we have a big sponsor that's in the area that may be co-hosting this with us. We'll watch for more details on that coming soon. And then, of course, the ever favorite Kubernetes KubeCon is just around the corner. The main CFP for KubeCon is closed. If you are a member or a leader of a work group or a SIG, you still are eligible to nominate talks through the 16th. But wasmCon is included again on the day. It will be on Monday, November the 6th. The CFP is still open until August the 6th. So please feel free to get those contributions in. And I think a bunch of these others are going to be essentially WASM related as well. My read from Telco Day, as well as the LF Edge stuff that's been going on, are that there are quite a few WebAssembly related talks that are flooding those CFPs as well. So if you have any questions or if you need any help with your CFP, don't hesitate to reach out. Bailey is, again, a program chair for wasmCon, and up on Twitter, the program chair, she's from Solo, or the co-chair with me for WASM Day is from Solo. Did I miss any, Brooks? Any other conferences?
And that's what I know of so far that we've got on the roadmap. I'm sure there'll be more, as all the CFPs and everything drop.
I think we should at some point pull our community and figure out where we should have some wasmCloud meetups. Like in DC.
I like that. Well, KCD, Kubernetes Community Day DC, is I think in the middle of October or September. And it's co-located with DevOps Day. It's in a gorgeous building right on the National Mall. It's in the Red Cross building down there. It'll be a nice 3-day hackathon. So Bailey, maybe we'll see if we can get you up for that.
That'd be fun.
September the 12th.
All right, everybody, we're kind of rolling right up to the hour here. So a really great demo from Jordan on the WIT providers. Thank you so much, Bailey, for coming in and talking about, not just WIT, but all things WASM components, and Liam for talking about the conferences that we have coming up. Are there any last second things that anybody wanted to mention before we hop off the live stream?
Maybe I'd only mention that I know Bailey and a bunch of the folks around the BCA ecosystem have been hard at work on a WebAssembly roadmap that we're hoping to get across the line in the next few days. So there'll be some authoritative documentation out coming that talks about all the new things that are coming in WASI Preview 2, what's in, what's out, and what's the status. So I think that'll be everybody should watch for that. I'm sure it'll show up on Twitter and all the usual places.
Awesome. Well, thanks, everybody. I'm going to go ahead and stop the community stream for now, but thanks for tuning in. And I guess we'll see you all next week for another fun